Take a look at this diagram of a library management system. You start coding, but then the client asks for online book reservations. A week later, they want email notifications, then online fine payments. Every new request forces your team to rewrite existing code, creating a tangled mess of overlapping changes and mounting bugs. Early software engineers looked at this chaos and established a strict rule to prevent it. Developers must finish one step of a project completely before starting the next. We can visualize this idea using a natural analogy. Just as water flows down a mountain and forms a river, never flowing upward, software development should move in exactly one downward direction. This structure is called the waterfall model. It is a linear and sequential software development lifecycle, where each phase naturally empties out into the one directly below it. By forcing a strictly one-way flow, developers prevent the confusion of overlapping code environments. But for this to work, the initial planning stage has to be completely flawless. The process begins with Phase 1, requirement analysis. Here, we document every single feature the client needs. If we are building an ATM system, we map out exact requirements like PIN login, cash withdrawal, and balance inquiries. Before moving forward, there is a strict rule: no going back. Every requirement is finalized and locked in. With the requirements locked, we enter Phase 2, system design. This is where we create the architectural blueprint. We map out how the login module connects to the transaction module and how both communicate with the database. Notice what is missing from these module boxes. At this stage, no actual programming code has been written. We are only planning the structure. The programming finally starts in Phase 3, implementation. This is the exact moment where developers convert our architectural blueprints into working code, writing the logic to match the initial requirements. These first 3 phases move the project through a strict, irreversible sequence, converting human requests into abstract blueprints, and then translating those blueprints into executable machine logic. Once the code is written, it moves into Phase 4, testing. The goal is to validate inputs against outputs to catch logic errors before release. For example, if a user requests a 500 rupee withdrawal and the system accidentally outputs 5,000, testers flag that incorrect output and send it back for a specific bug fix. After passing all tests, the software enters Phase 5, deployment. The validated package is installed in its target environment, allowing actual bank customers to start using the interface. Even after launch, the software requires Phase 6, maintenance. Over time, developers release security updates and performance patches to keep the system running smoothly. Look at this split screen. Based on the strict downward flow we've covered, which of these projects fits the waterfall model better? A payroll system with fixed tax rules, or a startup social app where user features change daily? Take a few seconds to decide. If you guessed the payroll system, you are correct. Its rules are clearly defined up front. The startup app, with its constant daily changes, would collapse under a rigid one-way system. The waterfall model's viability relies entirely on the predictability of the problem it is trying to solve. If the target environment is stable, the model works smoothly. If the target environment is volatile, the model breaks. A helpful way to remember this logic is to think about physical construction. Just as this animation shows a house being built, you have to pour the foundation before framing the structural walls, and it is physically impossible to paint those walls before building them. For your exams, you need to memorize this exact sequence. It flows straight down: requirement analysis, into system design, into implementation, followed by testing, deployment, and finally, maintenance. This structure provides specific operational strengths. Because the requirements are fixed early, the phases are clear to manage, milestones are highly visible, and the heavy emphasis on documentation creates a detailed record of the software. However, that same rigidity creates a fatal flaw. If a client attempts to change a core requirement late in the process, like adding a new feature during the testing phase, the entire downward structure gets blocked. This sequential architecture forces you to think clearly and algorithmically about how software goes from an idea to a finished product. It remains an excellent tool for learning the life cycle of code and a highly specialized method for real-world projects with concrete, unchanging goals.